Hello friends, here we are discussing rectifiers. The bridge rectifier shown in the figure below uses silicon diodes. So we are told to calculate for the DC output voltage and the DC output current. So the input here to the bridge rectifier is 12 volts AC. So what is coming out of the step down transformer is 12 AC voltage. Now, when it comes into here, then we'll have a DC output or a DC voltage appearing at the load resistor here. So let's look for the DC output voltage. So first of all, we need first determine the peak secondary voltage. So Vp secondary is going to be 12 times square root of 2, because to get the peak voltage for NAC, we have it as VRMS times square root of 2. So this is 12 times square root of 2, and this is equal to 16.97 volts. So we have to understand that at any instant, the output peak voltage will always equal to 16.97 minus 2 times 0.7, since we are using silicon diodes and the forward voltage drop is 0.7 volts. So since at any instant two diodes are conducting, so minus 1.4, and this is giving us 15.57 volts. So here two diodes are conducting and the voltage drop is 1.4 volts, 0.7 times 2. So that's why we have that. So now let's look for the VDC output. So the output voltage for DC that is going to appear across the resistor RL is going to be, since this is a full wave rectifier, so this is going to be 2V peak, okay, divided by pi. So this is going to be the other answer above times 2 divided by pi. So this gives us 9.91 volts. So the DC output voltage is going to be 9.91 volts. What about the DC output current? DC output current will be the voltage divided by the resistor. So this is 9.91 divided by 12. So divide by 12, and this is going to give us 82.6 times 10 power negative 3. So the output current would be 9.91 divided by 12 times 10 power negative 3. So 9.91 divided by 12 gives us 825.8 times 10 power negative 6. So this gives us 825.8, and what we are going to put is microamps, or this can be as well 1, 2, 3. This can as well be 0.8258 milliamps. So that is the DC output current and voltage. Now, if we wanted the peak inverse PIV for the full wave rectifier, this one, so PIV would be obviously the V peak secondary minus 0.7. So since they are real diodes, we shall get the VP, the V peak secondary, which is going to be the secondary peak is 16.97. So 16, the PIV will be 16.97 as 0.7. So that means the PIV rating of the diodes must greater than 16.27 volts.